Okay guys, we are continuing on with systems of linear inequalities. Quick recap of what we've done so far. We've learned that graphing linear inequalities is very similar to graphing equations. You've learned to graph y equals mx plus b. This is your y-intercept. It tells you where to go on the y-axis, up or down. And then you use this slope number to do your rise over run counts to go either up and right continually or down and right continually, depending on if it's positive or negative. Okay, if you don't have a slope intercept form, you may have a standard form, which means you could either solve for y, move all these other guys over here and solve for y, or you could do the cover-up method and get the x and y intercepts. You get 2 points that way, and you could get the line that way as well. Once you do that, you realize that that's the only similarity with these. That's about 95% of the work, is getting that line. But then before we draw the line, we have to look at the inequality. So we have learned that if it is greater than or equal to, the shading is above the line. So either one of these, the shading is going to be above the line. If it's either one of these, less than or equal to, the shading is below the line. We've also learned that the type of line we draw depends on these symbols as well. If it's one of these symbols that does not have the equal sign underneath, then it is a dashed line. So these are both going to give you a dashed line. If it has the equal sign underneath, that means it includes the line itself as part of the solution set, so it would be a solid line. So we've had 2 days of just solving inequalities, getting the variable by itself with an inequality. Then we had 2 days of graphing single inequalities, and now we're starting today where we graph 2 of these inequalities on one graph, and that's called a system of linear inequalities. So the system of linear inequalities is basically when you graph 2 different inequality lines with the shading. So you'll have not just one section of shading, you'll have 2 sections of shading. The solution to a system of inequalities is where you have the overlap of the shading and or the solid lines if they are both solid lines. Okay, so example, if I have a line going this way and it's dotted, and say my shading is below, and then I have another line going this way and it's solid, and that shading is above, notice there's a section where the shading happens twice. That would be right here. So anything that falls in this double shaded area will be part of my solution set. That includes anything that falls right here on this line, but that would not include things on this line since it's dotted. Okay, let's look at a few examples with the notes, and then we will do a little bit on the homework either on this video or another video. So let's take a look at this one first. So what is the graph of the system? So I'm going to go ahead and graph 2 different lines with this and get my shading, and then we'll go from there. So my plus 5 tells me to go up 5. And my slope is -1 or -1/1, so down 1/1 from there. And then up the other way. All right, so that's my first line. Since it is greater than or equal to, the line underneath there means it's a solid line. So I'm connecting my points with a solid line. The greater than means this line feels like it's greater than everyone else, or the solution is greater than everything else, so it's going to be above the line. That's kind of an ugly highlighter. Let's try another one. So there's the shading for the first inequality. The second inequality is negative 3x plus y is less than or equal to negative 4. Let's go ahead and solve it for y, which is actually really easy. One step. Let's do plus 3x plus 3x. And you have y is less than or equal to 3x minus 4. All right, so here we have a minus 4, negative 4, or down 4 on the y-axis. Our slope is positive 3 over 1. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. And you continue the pattern. And you can go the other way as well. Now this one is also a solid line. So we're going to connect these points as well with a solid line. This shading is also is actually a less than. So this one's feeling lower than everything else. So what determines below this line? When I draw straight down from the line, that is this side of the line. So I'm going to shade that. I don't have two different highlighter colors. I have a purple pen, so I'm just going to try that. All right. So we have the double shaded area here is where the solution to the system lies. We have the solution to the first inequality is all the yellow. The solution to the second inequality is all the purple. And both of them include the lines because they're solid lines. The solution to the entire system is all of this shaded, double shaded area of purple and yellow, including everything on this line, and including everything on this line, since they're both solid. So that's how you look at that. Let's take a look at another one. So we have example 2. Now this one, they do the double shading for us, and now we have to come up with the inequalities. So let's do that. Let's just ignore all the shading right now and just figure out the line. So here is a solid line, and it looks like the y-intercept is 1. It's going up 1. So I'm thinking, I'm going to label this line A, just so I know. And I'll label this dotted line, line B. So line A is going to be y equals, it's not really equals, but I'm thinking in my head, y equals mx plus b. So it's y, and it's something, and what is my mx plus b? Well, my plus b is plus 1. My slope looks like I'm going down 1 over 2, down 1 over 2, over and over again. So that is going to be negative 1/2. So negative 1/2 x. If it had been just an equation, it would be y equals negative 1/2 x plus 1. Since it's an inequality, I have to take a look. First of all, you know what? I started on the solid line and now I'm doing line B. So let me change it to line B. That's why it's really important to take a look at which one you're doing and label, because it's easy to get all the stuff mixed up. So let's do line B first. So it's still up at 1 and down 1 over 2, down 1 over 2. My equation is, inequality is going to be dotted line, so it's going to be no line underneath the inequality, and all the shading is below, so it's going to be less than. So y is less than negative 1/2 x plus 1. Okay, now let's do line A. Line A is also y-intercept of 1, which was what was confusing me. And this one is up 1 over 2, up 1 over 2. So my slope is 1/2 x, positive this time. And this one has shading that is kind of hard to see, but if you zoom in, you see a little gray area. This is like whiter here, this is grayer here. So the shading was also below on this one. It was all of this. In fact, let me go over the shading for line A with the yellow highlighter, since it didn't copy over very well. That's the shading of line A. Difference with line A is it's a solid line, so we're going to have the little line underneath it. It is also below though, so it's still less than. So this one's going to be y is less than or equal to 1/2 x plus 1. All right? So that's the system of inequalities represented by this graph. Let's go to the back. Okay, here we have two inequalities graphs, so we have a system. Again, I'll use the highlighter to show this one. In fact, actually, they're the same two lines, aren't they? So what they're asking here is the point where the boundary lines intersect a solution? Here's the point where the boundary lines intersect. They're crossing right here. They have the same y-intercept. Is that a solution? What do you think? Well, here's what I'm seeing. There's a solid line here, so everything on this line that's up here with the, it's down here with the double shaded area, everything on this line is part of the solution, okay? Everything on this dotted line, however, is not part of the solution because it's not part of this linear inequality, okay? So since this one is half solid, but for the other one it's dashed, it is not part of the solution because this line is dashed. So the fact that it's right on this line, it's not part of this inequality. So the answer is no, because one of the lines is dashed. So anything on that dashed line is not part of the solution set. Okay, let's go to this one. This will be the last example that we do on the video. Actually, I'll probably go and do the word problem, even though we're covering word problems on Monday. Systems of linear inequalities. So, graph this system on your calculator. Okay, we're going to do this one all in the calculator. So, let me find a calculator real quick, and we'll go ahead and I'll show you how you can do the double shading and everything in the calculator. So, I go to my graph screen. I like using the scratch pad most of the time. So I went to my graph screen and I'm going to go ahead and just dock B to get rid of any old stuff that might be in there from a previous problem. Here's my graph screen, and they're both in slope-intercept form with y by itself. So that makes it easy, but I don't have an equal sign here, so I'm going to hit delete, and I'm going to go ahead and go to greater than or equal to, and I'm going to type in x plus 2. There's my first line with shading. Now, it's not always easy to tell on the calculator screen if it's solid or dotted, but it's very easy to know just by looking at the symbol. That is solid. All right, the bottom one, I'm going to hit tab here on the calculator, and I don't have my stuff here. It goes in as a relation, so I'm going to go ahead and type y, and this time I have to type in my symbol. So if you'll notice, if I hit control equal, see in yellow right there, it has all the symbols in yellow above the equal sign. They pop up here as a menu option, and I want less than or equal to, so here it is. And I get my less than or equal to, and I put negative. This is a negative sign, not a minus, since it's in front of everything. So I use the negative button for x plus 1. Now, that's pretty cool that it shows you, and it does color changing for you, and shows you the double shaded area. Here's the blue, here's the pink, and here's the intersection of the shaded area. So it's really, really handy, okay? So I could turn on my grid lines If you're in the scratch pad like I am, it would be menu 223. If you're in a document, it's usually menu 263. And I could really eyeball it for a lot of these answers and find what points are in the double shaded area and what points are not. Since we have solid lines for both of them, any points that are on this line or this line up here would be part of the solution set. All right? Now,